used these germplasm before. You have heard Matthew and Ravi. They are already using, but this effort is little bit new. The scale we are doing it. So we are doing a huge scale genotyping, phenotyping, and mobilizing this material. So very systematic approach. So we are not looking specific trait in the beginning, but Mexican partners have the priorities for drought, heat, and kernel burnt, phosphor use efficiency, some leaf diseases. So we are taking those things, and I will let you know soon how this effort is going on. This is a collaborative efforts among large number of the team within the CIMMYT, Mexican partners, as well as international community. So as I mentioned that we are first major part is the characterization. So we have big players in characterization. I think Tom Payne and his team has done wonderful job to take more than 1,000 sessions from the gene bank and put into the field. Then a lot of the people here, Carolina, Prashant, and Mark Elias, they have done wonderful job to systematically keep the sample tracking system, take the tissue, extract the DNA, and send for the genotyping to Australia. Now we have the genotyping facility at CIMMYT, where this Carolina Sensaloni is the one who is coordinating that effort. So we have completed 50,000 sessions from the gene bank from CIMMYT and 25,000 sessions from ECARDA recently. So we have collected the tissue around, as I mentioned, 100,000 sessions, then extracted the DNA from all of them, and about 75 plus we have already the genotype information. It's a huge task. A number of people are involved. Then the another team is the characterizing at in the field level. There's large number of people involved. Matthew have screened more than 70,000 sessions for heat and drought, and Carolina is coordinating these efforts. Then we have phosphorus use efficiency. One is doing that part. We have done 2,000 sessions. Selected as sessions for phosphorus use efficiency. Similarly for disease, Pavan Kumar has screened around 6,000 sessions from the gene bank for various diseases, and Sridhar Bhavani has recently evaluated around 2,000 sessions for UG99 in Kenya. So there's Ravi, the best material, elite material from Ravi's program, we are using as the basic foundation to develop this bridging germplasm. So I think then I would like to say the quality, we have done 20,000 sessions for quality through Carlos and Javier are the main player who did this job. And then the major hallmark of this work is to mobilize this variation of the gene bank into the pre-breeding material. So the first challenge for us out of 140,000 or 120,000 sessions, what are the sessions we are going to take? As I mentioned that we are not focusing to identify the target trait. It takes us 2 to 3 years to identify the line tolerant to heat and drought. So the approach we have used, we have dig out the already available information in the gene bank. We use the advanced high throughput technology, GBS technology, to characterize the genetic diversity and nicely systematically characterize them, and then try to move those variations. These are the babies here grown under drought stress of the first breeding cycles. So we have used 240 exotic lines and 25 best elite lines of Ravi's program. So we make the breeding approach a little bit different, which we call linked top cross population. We cross exotic one with elite best one, then top cross again with the second best elite line. So in the TC1 F1 we have 75% blood from our best adapted lines, 25 from exotics. So we have a lot of issues when we are moving this diversity from gene bank into our breeding program due to the undesirable drag there. So I think we try to minimize those drag by using this approach. So now we have started with 40,000 F2s. Then out of 40,000 we planted them under drought and heat selection as selecting the spike, bulk them, move on forward. So then F5 we have selected 8,000 single plant, which were planted in Elbatan and Tlucas, and we look their phenotype and other things in the field. Then out of 8,000, we have selected top 1,500 lines, which are grown here in the drought. And last week we have planted under heat, and the next to that we have the reduced irrigation. So I'm excited. I am looking these babies, and they are happy under drought. Some are crying, but that's the way we move as a human being. We are looking ourselves how to feed the world, but that's one of the challenge we have. And I think these material also sent to some part in South Asia and also with the Mexican partners, depending upon the resources. So we need now more hands, more peoples, more linkage across the globe to see these impact or the potential of these resources. So I have visited last week 2 weeks in India. Then I have seen the material is selected for or evaluated for different diseases, even powdery mildew, yellow rust, and so many other things. So it has potential to explore under different target environment for different traits, because we are not initially selected these, but we have selected based on the information which is in the literature. We focus on drought and heat, but it can be explored, and I think this is the one small component we are contributing and complementing our best combination. As you all aware, that CIMMYT has contributed significantly to provide the weed germ problem so many years, and it has made a significant impact. But if we are looking now future challenge, this seed of initiative is a preemptive approach or the vision of CIMMYT leader or Mexican government to put this much money. Otherwise, we cannot do this. This is a huge effort, and large number of the peoples are involved. And now we need more peoples, more hands, more expertise to really funnel the value of this to address future challenge of climate change or the populations. So with these words, at the end, I acknowledge the CIMMYT governments, and I also pay to the thanks to our director, DG, who are continuously supporting this research work. And we have a lot of our efforts, peoples, eventuals, national staffs, Jessica, Fidel, and so many others who are working harder than us in the field to do all this work, because we have these is mostly we have the another trial where we have planted this material under heat condition. In to the right, we have this segregating material growing here, and there's a lot. We have developing a lot of the population allele mining panels. I think if any of you are interested to go through, I am very happy to show you one by one. It will take a little bit more time, but if anybody have questions or comment and suggestion, most welcome. This all again, I thanks to everybody who have contributed for this success.
Everything fast.